Hi, welcome dear students. Uh, Today we are going to discuss coordinate geometry, a new topic, right? Which is very important for any higher studies, right? For higher mathematics, if you pursue, right, you are you have to excel in this coordinate geometry, right? The total mathematics is based on this coordinate geometry. Let us recall, right? And our first topic is coordinate plane. Actually, our plan in this coordinate geometry is first we need to discuss about coordinate plane. Next, straight lines part. You see, this is what straight lines, right? The total topic coordinate geometry. What are the parts you are having? This is what coordinate plane, straight lines. Next you have pair of straight lines, like pair of straight lines. Number 4, circles, right? Number 5, parabola. We have parabola. Number 6, ellipse. Number 7, hyperbola, right? These are the different parts that we are having in this coordinate geometry topic, right? Now, before completion of your classes, we will first let us take up this topic coordinate plane and we will discuss. These are the remaining things we will continue. After this coordinate plane, we require this coordinate plane. Every student should know how to plot the points, how to draw the graphs of straight lines, different curves. That's why this coordinate plane topic is very much required. That's why we start with this and we start trigonometry, and afterwards we come to these topics once again and we are going to finish it, of course. Right, this coordinate geometry, my dear students, how we have and what is the importance of this topic. This is actually coordinate geometry is formed from algebra plus geometry, like this. See here, algebra plus geometry. These two, if you combine, you will be getting actually, if you want to do the plane geometry problems, it becomes a little bit difficult, more difficult. That's why there is one a great personality, okay, who came, right? His name is Rani Descartes. His name is Rani Descartes, right? He only discovered and found this topic coordinate geometry. How he has taken means, he taken geometry, he taken algebra, he unified these both and he formed a new subject called, what you call it as, coordinate geometry, like this. This is what you call coordinate geometry. This is also called it as, because you have used algebra, this is also called it as analytical geometry, like this. Analytical geometry, right? Fine, like this. And since he's in foreign countries, they used to call by the last name, whereas in our India we used to call by our first name, something like this. After his name, this is also called as Cartesian geometry, right? This is also called as Cartesian geometry, right? This is also called as Cartesian geometry. After his name, it is mentioned like that. If the coordinate geometry, analytical geometry, or Cartesian geometry, these are the different names that you are having for this topic, coordinate geometry, right? Actually, there is a small story about him. Rani Descartes is a school dropout from his school. His mathematics teacher, thrown out of the class, him, and he did some aimless journey, and he got enlightenment from the nature. He started doing meditation, and he sat and studied in the library of the New York, and he got interest in mathematics. He studied many things in geometry and algebra, and he got a grip over that. By God's grace, he got interest over that, and why can't we merge the subject algebra and geometry? That is the idea he got, and he developed this subject coordinate geometry, right? Fine. This is what it is now very much useful. You can do all geometry problems using algebra, and we can evolve any problem we can solve very easily by using this coordinate geometry. This is what a small story about this okay, coordinate geometry. Now we are going to okay. Now we will discuss this coordinate plane. Actually, the total plane, a plane is a flat surface. It is divided into 4 parts, right? It is divided into 4 parts by 2 real number lines, right? Like this. This is minus infinity, and this is plus infinity, and this is minus infinity plus infinity, right? This total plane is now divided into 4 parts by 2 real number lines. This is what you call origin, 0, 0. And this is what negative x-axis. And this is positive x-axis you are having like this, right? And this is positive y-axis, right? And this is negative y-axis. And the numbers we will have here 1, 2, 3, 4, 5, 6, 7, so on up to infinity. And here also 1, 2, 3, 4, 5, 6, so on up to infinity like this. And this is now here minus 1, you know, the real number line. To the right it will become 1, 2, 3, so on up to infinity you are have. And here to the left, okay, minus 3, minus 4, minus 5, so on up to minus infinity. Even for the y-axis also, the vertical one, you are having here 0, 1, 2, 3 up to plus infinity. Towards the down part you will have minus 1, minus 2, minus 3, minus 4, minus 5, so on up to minus infinity. And you see, my dear students, this total coordinate plane is divided into 4 parts. This is what you call quadrant 1. Okay, in quadrant 1 the points will be, see, this quadrant 1 is made up of positive x-axis and a positive y-axis. That's why, okay, any point on the coordinate plane is represented by some x comma y. Any point on the coordinate plane is represented by x comma y. Okay, x value and y value like that, right? Therefore, this is first quadrant is made up of positive x-axis and positive y-axis. That's why it is plus comma plus. Quadrant 1 is plus comma plus. Right, and quadrant 2 you have, and the points in this plane, every point will be in the form x comma y. X is here, the first coordinate is minus, and the second quadrant, this is the second coordinate is plus here like this, minus comma plus. Here the points will be, because it is made up of negative x-axis and positive y-axis, right? Now this is quadrant 3. Quadrant 3, this is minus comma minus like this. Okay, because this quadrant 3 is made up of negative x-axis, so negative y-axis. That's why here x is negative. Here, if whenever you take a point x comma y, okay, here also x comma y, any general point, it will be like that, minus comma plus in second quadrant, and in third quadrant minus comma minus. And fourth quadrant, obviously you can okay, obviously you can say that it will become what you are going to have, plus comma minus. You are going to have plus comma minus, right? This is the way how the coordinate plane is divided into 4 quadrants, so like this, right? Now if any point, suppose if I have something 2 comma 5, 2 comma 5 will be in the first quadrant you have got, and minus 2 comma 5, minus 2 comma 5 here like this, it is in the second quadrant. And also if you want to exactly, right, if you want to exactly locate this point, how to locate the point, that is important. Suppose 2 comma 5 I want means x value is 2 and y value is 5 like this. This is the point you have got now, 2 comma 5 like this. It's a basic thing how to plot the points, that's what we are telling to you. 2 comma 5. Suppose you want one more point, 3 comma 1. 3, x value is 3 and y value is 1. This is what the point, 3 comma 1. You have like this, right? Now you want minus 2 comma 5, minus 2, x value is minus 2 and y value is 5. This is what, minus 2 comma 5. It lies in the second quadrant because minus comma plus, right? Here x is minus 2, Here x is minus 2, y is 5, like this. Suppose you want to minus 5 comma 1, x value is minus 5 and y value is 1, like this. This is what minus 5 comma 1, like this you have got. Now the third quadrant, suppose you want minus 2 comma minus 3, this is x is minus 2 and this is minus 3, like this. This is what minus 2 comma minus 3 you have, like this, right? X is negative, y is negative, here like this you have, right? Minus comma minus, and if you want 4 comma minus 2, x value is 4 and y value is minus 2, this is 4 comma minus 2, like this we will represent, right? It is in the fourth quadrant. Now if you want 0 comma 0 will be here, 0 comma 0 is what the origin you are having here, like this. Suppose you want a point 7 comma 0, x value is 7, y value is 0, it will lies on the x-axis, it will lies on the x-axis. 2 comma 0, 2 comma 0 will lie here, 1 comma 0, 1 comma 0 is here, right? This point is nothing but 1 comma 0, and this is 2 comma 0, and this is 7 comma 0, like this, and this is now 0 comma 6. On y-axis any point if you take whose x value becomes 0, on x-axis if you take any point whose y coordinate becomes 0, and here you want to suppose this point is minus 2 comma 0, like this, minus 2 comma 0, and you want 0 comma minus 4, this is what 0 comma minus 4, right? On y-axis the x value becomes 0, like this, the x value becomes 0, right? Fine. Like this we have different points on this coordinate plane. Actually in this coordinate plane, x, the name given to x coordinate is nothing but abscissa. The name given to x coordinate is abscissa, and the name given to y coordinate is ordinate, right? These are the names given by Rani Descartes. Okay, these are the fundamental basic elements of coordinate geometry topic. Okay, without point, actually the thing what he found is, right, what he found is, actually Rani Descartes found a great invention. What he told is there is a one-to-one correspondence between the points of the plane and the coordinates. Suppose what he told is, if you give any point, suppose if you give any point, he told that he will give the address of that one, like, right? That means so randomly you show some point here, like this. Okay, if you show some point here, suppose anything, you take one point randomly here, you draw one horizontal line and you draw one vertical line. What is this? This horizontal line will give you x equal to 4 and this vertical line will give you y equal to 6. This is what the address of this point, 4 comma 6. Here x is 4 and y is 6. This is what the address of the point. What he found is, you show randomly any point. Suppose you take here like this, you draw from this horizontal line, you draw from this vertical line, like this. Here this horizontal line value, here you have something like from here to here, this is what x value, this is something like between minus 3 and minus 2. This may be something like x value minus 2.6, maybe here like this, minus 2.6, or maybe it is minus 2.3, and the y value equal to here 3. Therefore this point is minus 2.3 comma 3, like this. That means you show any point, he will give the address. Address means he can able to give x comma y, right? That means, as I told you, okay, if you give any point, he will give the address, or you tell the address of the point, he will you tell the address of that point, he will show that point. Suppose I want a point which is 5 comma minus 2. 5 comma minus 2 is here, like this. This is x value is 5 and y is minus 2. 5 comma minus 2 is here, like this, right? We have got, once you give the address, we can locate the point, or you give the point, we will tell the address. That is what the one-to-one correspondence, that is what explained by Rani Descartes, right? Suppose you give 1 point 6 comma minus 1, 6 comma x value is 6 and y value is minus 1, like this. This is what one-to-one correspondence between address and the points. Either you show the point, we will tell the address, or you give the address of the point, we will show the point. Like that, there is a one-to-one correspondence between the points and the address of the points. Once again, if we come to this x coordinate, he named it as abscissa, like this, right? Abscissa. And y coordinate, he named it as ordinate, like this. Maybe probably because these are the basic fundamental elements. Any point means here what? X comma y. This is what the point on this coordinate plane. This is the basic and fundamental point that is required for this coordinate geometry. He named maybe his daughter's names or maybe his son's names. We don't know in foreign countries. By the names we cannot find the gender of it, of course. Abscissa or ordinate. Abscissa maybe their son's names or maybe daughter's names. He got the named main things here x and y as like this. The coordinate plane is developed, right? And you know that how to plot the points on that, right? Now, since it is the beginning of the basic class, okay, some students may don't know how to plot the points. For that, we are giving one small exercise. Plot the following points on the coordinate plane. Right? You have now you got this is one real number line. This is negative x-axis you are having here, and this is positive x-axis you are having here, and this is positive y-axis, and this is negative y-axis you are having here. Now we need to plot these points on this coordinate plane. First point is 0, 0. This is what the origin, right? 0, 0 is what? This is the point, first one you are having here. Now the second one, 1, 2. X value is 1, you take x value is 1 and y value is 2. This is what now? 1, 2, like this. Right? 2, 5. X value is 2, you take horizontally 2 and y value is 5, like this. This is what now? 2, 5. Right? Next, minus 2, 5. X value here is minus 2 and y value is 5. You take here like this. This is what? Minus 2, 5, like this. Right? Next, minus 3, minus 2. This is x value is minus 3 and y value is minus 2, like this. This is what now? Minus 3, minus 2, like this. And 4, minus 2. This is x value is 4 and y value is minus 2, like this. 4, minus 2, like this. We have next 2, 0. 2, 0. Right? It is on x-axis. X value is 2 and y value is 0. This is now 2, 0, like this. 5, 0. 5, 0 is the point here, like this, which is also on x-axis. 0, 7. 0, 7 is this point, okay, which lies on y-axis, right? Whose x value becomes 0. 0, minus 2, right? 0, minus 2 is this point, which lies on negative y-axis. 0, minus 2 is this. And 0, 1. 0, 1 is this point, which lies on y-axis. Like this, you can plot these points very easily, right, on the coordinate plane. Now, let us discuss some results which are based on this, and we develop the subject now like this. Now, we have got some important remarks, okay. Based on the discussion what we have got, these are some important remarks that we have got. Now, we will understand in more better way with the diagrams. The first remark is a point P x comma y is on x-axis if and only if y equal to 0. That is what I told you also. Okay, if you have any point, if this is the coordinate plane that you have like this, right? And you know this is x-axis and this is y-axis, right? If you have any point on x-axis, this point, these all points, what I told you that this is 1, 0, 2, 0, 3, 0, like this. Whose y coordinate becomes 0. Here also you have minus 1, 0, minus 2, 0, like this. Whose y coordinate becomes 0 on x-axis. That is what the first remark. And the second remark is a point on y-axis means if and only if, this is what? If and only if x equal to 0. On y-axis, suppose this point, if you take, this is something like 0, 5, 0, 4, 0, 3, like this, right? And 0, minus 1, like this. 0, minus 2, like this. These are the points on y-axis whose x coordinate becomes 0, right? Whose x coordinate becomes 0. Now, The third one, a point is an origin. Origin means we told that x will be 0. This point, see where the point of intersection of x-axis and y-axis. This particular point, what you call it as origin, like this. O. It is denoted by O, origin. Right? This is what origin. Where x is 0 and y is 0. It is the point of intersection of x-axis and y-axis. Like this you have now. Now the fourth remark is a horizontal line is parallel to x-axis. If and only if all y coordinates are same, right? All its y coordinates becomes same. Suppose you take 1, 1 is the point, 2, 1 is this point, 3, 1 is this point, 4, 1 is this point, 5, 1 is this point. You see, my dear students, this is 1, 1, right? And 2, 1, 3, 1, like this we have. These all points y coordinate is 1. You observe, that means the same height. When you join these points all like this, and you join like this all these points like this, right? You are going to get a horizontal line which is parallel to x-axis. A line is parallel to x-axis means if and only if all of its y coordinates become same, like this. Y coordinates becomes same. That is what this fourth remark. Now regarding the fifth remark, a vertical line is parallel to y-axis if and only if all x coordinates are same, right? X coordinates are same. You see, for example, my dear students, this is what the graph you are having here. This is what x-axis and this is y-axis. Suppose if I take this point, this is what 3, 0 on x-axis. This is now 3, 1. This is 3, 2. This is 3, 3. This is 3, minus 1. 3, minus 2. 3, minus 3. If you join all these points, now you are getting a vertical line which is parallel to y-axis. And if you observe all x coordinates, you see x coordinate is 3, like this. Therefore, the equation of this line becomes x is equal to 3. Right? The equation of this line becomes x is equal to 3, like that. A vertical line is a line parallel to y-axis in which all x coordinates are same. Right? Now, one important derivation and important concept in coordinate geometry is distance between 2 points. The statement is the distance between any 2 points you take on the plane, any 2 points. Let us take that first point as A, x1, y1 and B, x2, y2. We take B, x2, y2. Then its distance between them, AB. Okay, distance between AB is given by square root of x2 minus x1 whole square plus y2 minus y1 whole square. Now let us try to get the proof of this, my dear students. Let us take the graph like this. You can take any 2 points, right? Okay, this is what you have x-axis, right? And this is what y-axis you have here. And this is negative y-axis and negative x. Anywhere you can take 2 points here, like that. Suppose I am taking here 1 point here, and anywhere you can take it. It is not a matter like that. If I take fine here, right? We take x1, y1 1 point and x2, y2, right? Is another point like this. You see, my dear students, here this is what we have x1, y1 like this. A, let us call it, and B as x2, y2 like this. Now let us try to find distance between these 2 points, right? How you are going to get that is you draw one horizontal line like this, you draw one vertical line like this. Now you see, can you identify this point? This point is nothing but you have here now. See this point, this whose x coordinate is nothing but here x2. Here for this point x coordinate, this is what x2, and this height is nothing but y1 like this, y1 like that. And you know that whenever this line is now parallel to x-axis, it is a horizontal line. Then let us call this point as some C. Now AC is a line, horizontal line parallel to x-axis. This distance, and you see, my dear students, this is nothing but x2 and this is nothing but x1, and this part you are going to get it as x2 minus x1. This total distance is x2 and this is x1 means, and this part you have Okay, we will get it as x2 minus x1. The same concept here. You know that this point is this point is now the total y2. This point is what? Y2 you are having here. And this is now you have here y1. We need this one. We need this one. This is given by y2 minus y1, right? Right, because this total height is y2 and this is y1. Then what is this means? Y2 minus y1. If you do, you will get it that. From this, you see, my dear students, what you have got from triangle ABC. Here triangle ABC, in which angle C equal to 90 degrees. Because you draw one, this is a horizontal line, this is a vertical line. The angle between them is 90 degrees. Okay, and you got from that AC is equal to x2 minus x1, like this. And you have got BC equal to y2 minus y1. And we need the distance between 2 points, you know that AB. And you know that by Pythagoras theorem, AB square, you know, by Pythagoras theorem, AB square is equal to, okay, AC square plus BC square, like this. From that AB, distance between 2 points, AB is nothing but root over AC square plus BC square. You have got like this. Now this is AB is equal to, okay, AC is nothing but x2 minus x1 whole square plus y2 minus y1 whole square, like this, right? AB is equal to this. Now you got nice the formula. Distance between any 2 points, we have taken a x1 y1, b x2 y2 as AB is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Like this we have got. Now see, my dear students, for example, suppose we have one remark under this, right? The remark is, suppose you have A as x1 comma 0, right? And B as x2 comma 0, both are lying on x-axis. Then the distance between them AB equal to square root of, you know that, right? Okay, fine. You are going to have x2 minus x1 whole square plus 0 square. That means the distance between them AB is nothing but you have got modulus of x2 minus x1. Modulus of x2 minus x1. Now we have remark 2. If A 0 comma y1 and B 0 comma y2, these are 2 points lies on y-axis, then the distance between AB is square root of okay, 0 minus 0 whole square plus y2 minus y1 whole square. That is nothing but square root of right, y2 minus y1 whole square. That is nothing but, you know that in mathematics we know that square root of x square equal to mod x. By that modulus of y2 minus y1, that is the absolute distance between, right, absolute distance between y2 and y1, right? Like that we will be getting that particular one. Now remark 3, if A is origin 0 comma 0, B is any point x comma y, then the distance between A and B is AB is equal to square root of x minus 0 whole square plus y minus 0 whole square. That means square root of x square plus y square. Okay, this is the thing what you have got now. Now one basic problem we have, find the distance between the following points. The first one is A 5 comma 3, B 2 comma 1. Okay, and B is this. Let us do this here, my dear students. A 5 comma 3, we have like this, and this is nothing but x1 comma y1. You can treat it as like this. And B point they given 2 comma 1, that is nothing but x2 comma y2, like this you treat it. Now the distance between A and B, the formula is you know, x2 minus x1 whole square plus y2 minus y1 whole square, like this. This is nothing but, okay, x2 is here 2 minus 5 whole square plus 1 minus 3 whole square, like this you have got. And this is square root of 2 minus 5 is minus 3 square. Minus 3 square is what? 9. And 1 minus 3 whole square minus 2 square, that is what? 4. Right? Square root of 9 plus 4, that is root over 13 is what the distance between that you have got. Now the point Okay, the second problem you have got a minus 1 comma minus 2. This is what x1 comma y1 you take like this, and b is you have got 2 comma minus 3. This you take it as x2 comma y2 like this. Now the distance AB is equal to square root of x2 minus x1 whole square. 2 minus of minus 1. 2 minus of minus 1 whole square plus y2 minus y1, that is minus 3 minus of minus 2 whole square like this. And this is nothing but 2 plus 1 whole square, 3 square plus minus 3 plus 2, that is minus 1 whole square. You have like this. Okay, minus 3 plus 2 like this. This is now 9 plus 1, that is root 10 is what the distance between this following points. Like that we will have this problem. On this first video I explained the introduction, basic concept, what is coordinate plane, how to locate the points, distance between 2 points and their important remarks, and a basic problem on this. My dear students, thank you for watching. Thank you. Please subscribe and share it and like it.